Okay, let's take these ideas of linear velocity and angular velocity, and let's do some applications of them in these examples. So you can see I have examples and think, pair, share. Of course, you can just pause the video now and try all of this on your own. I have the answers for each, written down here below if you want to try it and check. But first, what I'll do is I'll give an example and I'll explain that. Then you can pause the video and try the think, pair, share on your own. And if you get the wrong answer, then you can resume the video and watch my explanation of it. Okay, so let's look at this first example. Find the angular velocity, and we want the angular velocity in degrees. What we have to work with is a water wheel completes one rotation every 5 seconds. All right, so let's maybe take a quick little look at that. So we've got a water wheel. So a water wheel will have a platform up above that water will run off of. And as the water comes off the platform, it goes onto the wheel and the wheel rotates. So what this is saying is that the wheel will make one full rotation around every 5 seconds. So what is the angular velocity? Okay, well, angular velocity, we use the letter W for that. And the equation that we have is angular velocity is equal to the degree measure rotated divided by unit of time. Now we want this in degrees, so one full rotation is equal to 360 degrees. So that will be our theta. And then our unit of time was it took 5 seconds to go 360 degrees. So our angle theta is going to be 360 degrees over 5 seconds of time. Let me go ahead and put those in parentheses to show that I just substituted those values in. All right, so now it's usually typical to go ahead and divide the denominator into the numerator so that we get like degrees per 1 second. So if we divide 5 into 360, we get 72 degrees per second. So this is our angular velocity in units of degrees. Okay, so use this example and as a model and do the think, pair, share on your own and see if you can do it. Okay, so this think, pair, share is very much like the previous one, except now, instead of degrees, we want to calculate this in radians. All right, so it's the same scenario with the water wheel, and we're going to use the same formula. So it's angular velocity is equal to the angular measure divided by a period of time. Now, one rotation around the water wheel isn't going to be 360 degrees. It's going to be 2 pi radians. So that is going to be our theta. And our amount of time that it took to do one full rotation was 6 seconds. So now we can just substitute 2 pi radians and 6 seconds. And we could simplify that as pi radians per 3 seconds. Okay, that wouldn't be too bad to leave it in, but if we wanted to have radians per second, we would divide 3 into pi, It doesn't go evenly, but I'm going to end up rounding. It's going to be approximately 1.05 radians per second. So that would be the angular velocity of that water wheel completing one rotation in 6 seconds. All right, so let's try something a little more challenging, and that's the next example in think, pair, share. Again, I'll work through this example, and the think, pair, share is very similar to it. Use my example as a model and try and do it on your own. Okay, so what we have is we have a bicycle with 28-inch wheels rotating at 180 RPMs. Now, if you're not familiar, RPM means revolutions per minute, which a revolution is actually one full rotation per minute. Okay, so let's take a look, at our scenario here. So we've got a bicycle tire. Okay, so there are the forks. Then here's the handlebar, and then the rest of the bike to something like that. Okay, it's got 28-inch wheels. So the fact that it's 28 inches, that is referring to the diameter of the tires. But what we're going to need is we are going to need the radius. And so the radius is half of that, or 14 inches. So the diameter is 28 inches, which means the radius is going to be half of that, or 14 inches. Okay, so we're going to need to convert this into a radius here. All right, so we need to find the linear velocity. So linear velocity is equal to angular velocity times the radius. Well, we know what this is now, but we don't have the angular velocity. This is unknown. So we cannot calculate what we're trying to find, linear velocity, until we get that angular velocity. So what we need is angular velocity. And angular velocity is equal to the measure of the angle rotated per unit time. So what do we know about the unit of measure that was rotated? Well, we know that we have 180 revolutions per minute, or 180 rotations per minute. So we have 180 rotations per minute. Well, we're going to need to, in order to have angular velocity needs to be in units of radians per unit time, or radians per minute. So we need radians to be up here in the numerator. So what we could do is we could put 2 pi radians. And what does 2 pi radians represent? 2 pi radians represents 1 rotation. Now, why did I think to put radians in the numerator and rotation in the denominator? Because this goes to the cancellation of units idea that I taught earlier in the chapter. You'll notice that rotations is in the numerator and the unit of rotations is in the denominator. So these two units will end up canceling out. And that leaves us the two units that we want left, radians per minute. So now we just need to carry over everything in the numerator. So we've got 180 times 2 pi radians all over 1 minute. So our angular velocity comes out to 360 pi radians per minute. This is the angular velocity that we need in order to calculate linear velocity. Okay, but here's a little bit of a rub. This linear velocity that we calculate, it has to be in miles per hour. And we got a problem here because our units are in inches per minute. So we need to not only do this multiplication, but we also need to do a unit conversion at the same time. Okay, it's not as hard as it sounds. So let's think of it in terms of unit cancellation. We want to end up with miles per hour. Well, let's first worry about converting everything that we've got into miles. And so when we're thinking about converting things from miles, well, we can go from miles to feet, and then from feet into inches. Right? Right. And so we can, so if we think about miles going to feet and feet going to inches, inches is what we've got, and that'll get us back to miles. So let's start with a known. We know that 1 mile has 5,280 feet. And we know that, so that does that conversion. And then we know that 1 foot has 12 inches. Okay, so what we've done is we've set it up so that feet, use a different color. We've set it up so that feet will cancel feet. And now we need to cancel out inches. So what do we have here in our equation that has inches? The radius. And there's 14 inches. So this represents this R component to the problem. We've taken 14 inches and we've done some unit cancellation, and we're going to end up with miles. Okay, now we need to multiply that times our angular velocity. Okay, but angular velocity, we want hours to be in the denominator. And we've got minutes to work with. So we want to convert hours to minutes. And we want minutes to be in the denominator. Well, let's see here. So we know that we have, all right, sorry for that. I kind of had a thing I was thinking about. Um, okay, so we've got, I just lost my train of thought. I'm sorry. So hours per minute. Okay, so we want hours to be in the denominator. So we've got 1 hour is equal to 60 minutes. And now we know that we've got 360 pi radians per 1 minute. So this will cancel out our units of minute with minute. All right, so we're almost there. Here we've got miles, here we've got hours, but we have this unit of radians that we need to cancel out. Hmm. But actually, these units of radians we don't need to cancel out. We just had to make sure that that's what our measurement was in radians. So that actually means that we're done. All right, so minutes will cancel with minutes. Inches will cancel with inches. Feet will cancel with feet. And that'll leave us with miles per hour. So everything that we have in the numerator, we've got 14 times 60 times 360 pi, and that's going to be miles per 5,280 times 12 hours. And when you put the numerator into the calculator and divide that by the denominator, you're going to end up with approximately 15 miles per hour. So that is the linear velocity. Okay. So take this idea as a model and try to solve the next think pair share. Again, unit cancellation is a really good skill to develop um, because you'll have to convert units in other disciplines because they'll have their own units that will have many different levels or equivalences. So learning how to do something like this is really helpful. And if you kind of don't know where to start, the easiest place to start is look at the units that you need to end up with and start from there. All right, go ahead and pause the video and give the next one a try. Okay, so maybe you didn't get quite 104 miles per hour, um, or you did and you just want to see how I solved it. So we're going to find the linear velocity, okay, which is v equals angular velocity times the radius of a car with 27-inch tires rotating at 1,295 revolutions per minute. So if the diameter of the tire is 27 inches, then we know that the radius is going to be half of that, or 13.5 inches. Okay, so this value of R we've got, what we need is the angular velocity. So the angular velocity, okay, is equal to our angular measure divided by unit of time. And we know that we covered 1,295 rotations per minute. Okay, and we know that we can cover 2 pi radians in one rotation. So rotations will cancel with rotations, leaving us with radians per minute. Okay, and that'll give us 2,590 pi radians per minute. So that is our angular velocity. All right, so let's calculate our linear velocity now, because now we know what the angular velocity is and we know what the radius is. So again, we need this to be in miles per hour. So we want to make sure that we end up with miles in the numerator. So 1 mile is 5,280 feet. And we know that in 1 foot, we've got 12 inches. And our radius is in inches. That's 13.5 inches. So inches and inches cancels, feet with feet cancels, and we're left with miles. So that tells us we've got this part of it correctly. Okay, now we need hours in the denominator. And we're dealing with hours and minutes. So let's put 1 hour here in the denominator. And in 1 hour, we know that we've got 60 minutes. And our angular velocity is 2,590 pi per 1 minute. So minutes will cancel with minutes, and we're left with just hours. So, the fact that we've put in our value for angular velocity and radius, and we've put it in such a way that all the units cancel except for the units we are looking for, we just have to now complete the multiplication and division and we're done. So we've got 13.5 times 60 times 2,590 pi, and that's going to be miles, and that's over 5,280 times 12 minutes. And that should come out to about 104 miles per hour for our linear velocity. Okay, so a car with 27-inch diameter tires going at 1,295 revolutions per minute is going a little over 100 miles an hour. Okay, so you may have had a different way to solve it, and it's fine. I just choose to maybe solve it this way because I want to also help demonstrate to you, how to do unit cancellation with problems and how that helps you keep straight, what should be in the numerator and what should be in the denominator. So you end up with a better chance of getting correct answers every time. Okay, let me know if you have any questions.